All right, today we're doing something a little different. We're not just going to look at a bunch of code. Instead, we're going to follow one developer's epic journey, a quest really, to master one of the most fundamental and honestly most misunderstood design patterns out there.
So picture this. It's Monday morning. Our hero, a developer we're going to call Sharma Ji, walks into the office, and it is just total chaos. I mean, the printer area, it's basically a war zone. And you could just imagine this is what's going through his head.
So what's the problem? Well, it turns out 3 different developers have all decided to create their own official printer manager. Yeah, you've got one for accounting, another for HR, and a third just for executive reports. The result? You guessed it. Lost print jobs, the same document printing out 3 times, just a whole lot of frustration all around.
Okay, so let's get into it. Sharma Ji is looking at this mess and a light bulb goes off. He remembers this powerful tool from back in his training days that seems absolutely perfect for this job, the Singleton design pattern. He's like, right, it's time to bring some order to this madness.
So, what exactly is a singleton? The core idea is actually pretty simple, but it's also incredibly powerful. It's all about designing a class in a way that forces it to have only one instance. That's it. Exactly one object can ever be created from it. One class, one instance. The end.
And what's really cool is how it works. It's basically just 3 key moves. First, you've got this private static variable that holds on to the one and only instance. Second, and this is crucial, the constructor is made private. Think of it like locking the door so nobody else can just come in and create new instances whenever they want. And third, you have a public static method that acts like the one and only key. It's the only way to get that single instance. And believe it or not, just like that, it works. The feuding developers all start using the one printer manager. Order is restored, print jobs are flying out correctly, Sharma Ji is the hero of the office. But, as you can see, that little "for now" on the screen kind of gives it away. This story is far from over.
Yeah, that victory? It was surprisingly short-lived. See, the very pattern that solved one problem was about to unleash a whole host of new, hidden dangers, the kind of stuff he never, ever saw coming.
So a week goes by, and then the QA day team drops a bombshell. They're doing some heavy load testing, and they're reporting something Sharma Ji thought was literally impossible. They're seeing multiple instances of his supposedly bulletproof printer manager. The chaos, it was back.
And what was the culprit? A classic race condition. When a bunch of threads hit that getInstance method at the exact same time, they all check if the instance exists. They all see, nope, it's null. So what do? They all race to create a new one, totally blowing up the whole singleton guarantee. You get 3 threads, you get 3 instances. Oops.
So Sharma Ji is wrestling with all these complex threading solutions. Synchronized blocks, double-checked locking, and then a senior architect comes along. She shows him a much cleaner, way more robust way to do it. One that actually uses a core feature of the Java language itself, the Enum.
Okay, so why is this so much better? The crucial thing to get here is that using an enum for your singleton is like getting a whole bunch of security features for free. The Java virtual machine itself guarantees that an enum instance is only ever created once. That means it's inherently thread safe, and it protects against a bunch of other sneaky attacks right out of the box. It's just built in. So just when Sharma Ji's feeling pretty good about himself, thinking he's finally mastered this thing, a colleague from the security team, a guy named Vikram, strolls over. He's got this little grin on his face, and he drops another bombshell. Turns out, even this supposedly bulletproof pattern still had some holes.
And Vikram didn't just tell him, he showed him. He pulled off 3 pretty devastating attacks. First, he used reflection to just bypass the private constructor entirely. Then, he used serialization to create a whole new instance just by reading it from a file. And for good measure, he used cloning to make an unauthorized duplicate. Bam, bam, bam. Each attack completely shattered that one instance rule.
But here's the thing. For every attack, there's a defense. So Sharma Ji got back to work. He started fortifying his code. He added a check right in the constructor to block reflection attacks. He implemented a special method called read-resolve to handle serialization properly. And he overrode the clone method to just throw an exception. Now his singleton was truly secure.
All right, so fast forward 6 months. The singleton is working like a charm, no issues. But then a new team lead, Sarah, joins the company. She's looking at the code,
And she asks this one simple question. A question that doesn't just challenge the solution, but the entire approach.
And Sarah's question wasn't, does this work? I mean, it obviously did. Her question was, is this the right tool for the job? She pointed out that the very nature of the singleton, this global, all-powerful single object, can create all these hidden problems that you just don't see at first.
And this is where you see two totally different philosophies clash. Dependency injection, the whole idea is that instead of an object going out and finding its own dependencies, they're just handed to it. They're injected from the outside. So yeah, the singleton gives you that easy global access, but it also creates really tight connections between your code and makes it a nightmare to test. Dependency injection, on the other hand, it's all about loose connections, which makes your code way easier to test and maintain.
And for Sharma Ji, this was a total aha moment. He suddenly realized with dependency injection, you could easily swap in a fake mock printer for your tests without ever having to touch the real hardware. Components become flexible, your dependencies are spelled out crystal clear, and you completely eliminate the dangers of having this hidden global state that can mess things up.
Okay, let's jump forward one last time. It's a year later, and Sharma Ji, he's not just the guy fighting fires anymore. He's become the go-to expert on design patterns, and now he's standing up in front of his whole team, ready to share everything he learned on this crazy journey.
And he didn't just tell his story, he gave them something practical, this simple, actionable framework. He told them, look, before you even think about writing a singleton, stop and ask yourselves these 4 questions. It was all about helping them choose the right tool for the right job, not just reaching for the same old hammer.
And then, during the Q&A, someone asked the perfect question. When should you just not use a singleton at all? And his answer was so powerful. He said, when you find yourself fighting the pattern, it's time to consider alternatives. Basically, if making the pattern work is harder than solving the actual problem, you're probably using the wrong tool.
And that really was his biggest takeaway. The whole point isn't just to use a pattern because it's in a book and you know its name. The real goal is to solve problems well, to create code that's clean, that's testable, and that someone else can actually maintain down the road.
Which brings us to the final piece of wisdom from Sharma Ji's entire epic journey. He went from the total chaos of the printer room, he fought battles with threads and security holes, and he came out the other side realizing that true mastery, it isn't just about knowing how to build something, it's about knowing when not to. So as you go back to your own work, whether you're facing your own printer crisis or something completely different, this is the question to keep in your head. What problem are you actually trying to solve? Don't start with a solution looking for a problem. Start with the problem itself. And that's all for this explainer.